And I'll do examples too, so it makes it a little bit clearer. So again, arrays are like lists, and they can be lists of numbers, integers, doubles, or words, strings, or in the case of a string, they can be composed of characters. So a string is essentially an array of characters, okay? And with that being said, if I have a list, same thing with like if I have a grocery list, I know what the first item on that list is, and I know what the last one is. I can look at the list. Well, with Java and arrays, the first index or the first item on that list is index 0. The last item is whatever the length of that full array is. So in this case, this array is of length 15 minus 1 because we started at 0. We didn't start at 1. We started at 0. So the list minus 1 is the last index of our list. What are the benefits of an array? So if we have several numbers to keep track of, we have a whole bunch of names to keep track of, we can add them to a list, and that makes it indexable, which we can also sort the list very easily. We can sort the array very easily. So that makes finding the largest and the smallest numbers trivial, right? If we sort the whole list from in ascending order, so from smallest to biggest, if we sort it, that means the smallest one will be at the first index, the biggest one will be at the last index. So it makes finding the largest and smallest trivial. Also, we can loop through the array really easily and find and do whatever we want to do with the array. So how do we declare arrays? Well, very straightforward. Just like we declare other variables, we have the array data type, which in this case is an int, brace, and then whatever we want to name this array. So in the code, if I go to code over here, let's delete this. All right, so if I have code, I can declare an array, the data type, brace, and then whatever I want to name it. Let's name it scores. And there you go. There isn't, or actually, let's name it points. There's my array, and I named it points, and it's of data type integer, right? I declared it. So to actually create the array and actually make the array in memory, right, we actually have to use the new keyword. So whatever we named it equals new whatever, integer or double or string. Plus, inside the brace, we need to put whatever size we want for this array. So if I go back to the code, I created my array here. I declared my array there, but to actually create it, points equals new, whatever my data type is, and then the size. So this example, I'm going to do points in an 82 game NBA season. Okay, that's what my array is going to represent. Each index inside the array is going to represent a game in the entire season, and whatever the value of those indexes are going to be how many points this player scored, whoever it is. So that is creating and declaring an array on two different lines, right? First we declare it, then we create it. However, we can do all of this on one line if we want to. So what I mean by this is instead of having these two lines, I can do this right here. Int brace points equals new int of size 82. All right. Let's see, make sure I got everybody in attendance. I think I got everybody.
Did you mark be present?
Yeah, I got you. Okay. All right, so like I said, creating the array in one line is doable as well. You don't have to do it in 2 lines. You can do it in 2 lines if, say, for example, there's a certain condition that you want your array, the size of your array to change based upon. So for example, let's say I have another array of double prices, right? And this is a grocery store, and depending on what type of item it is, it can have several different prices, right? So let's see, string item equals apple, right? An apple can have several different prices depending on the type of apple, blah, blah, blah. So my prices array will change based on how many apples there are. Why doesn't it look like this? Oh, I know why. All right. So if I say if item dot equals apple, I want my prices array. Do I have enough brackets? Okay. I want my prices array to equal, there are 20 different apples in this store. So I want to have 20 different prices. Oh, I did it again. These double quotation marks are throwing me off because in Python and in JavaScript, it doesn't matter what you use. So if item dot equals apple, I want the prices array to be a size 20. There's 20 different apples. Else if item dot equals orange, let's say, for example, there's only 10 oranges. So I want my prices array to be of size 10. So that's when you would use declaring it in one line and then creating it in another. But in this class, for the most part, we probably won't have to deal with that. We'll probably just do everything on one line, which is what I did up here. Okay, I'll let that sit there for a second. All right. I'm going to go ahead and delete this because we're not going to use this prices. We're going to use the points. All right. Again, the length of our array is accessible by using a dot length method. And if you recall, like I just said, I think 2 slides ago, the index of our array goes from 0 to length -1 or size -1. And so we can get the length using the dot length keyword. We use our array name, dot length. And so if I go back here, we know we just created an array of points of size 82 because there's 82 games in a typical regular season. So if I system.out.println points.length, I would expect that to print out an 82. Run this, and you see down here, it prints out 82. That's the length of our array. However, our array, the actual items or indices in our array range from 0 to 81, right? Length -1. 81 is our last index, not 82. The full size of the array is 82, but the indices range from 0 to 81. It's always length minus 1, okay? For every array, it's always length minus 1. Here are the default values. For number arrays, the default value is 0. For character string arrays, that's the default value. And for Boolean arrays, the default value is false. All right. So what I mean by that is, if I loop through this entire array and I look at each index, it will be a 0 because I haven't set it equal to anything yet. Let's just show an example of the size of. I just did this, an array of exactly size 10, right? Int numbers equals new int 10. Therefore, that array will be exactly size 10. There will be 10 indices in our array. Arrays are also good for memory management. Each index in our array is sequentially placed in memory, meaning it's right next to each other, right, in memory. If we just create random variables, they can be placed anywhere in memory, separated from one another. And so the array makes better efficient use of our memory as well. We can create arrays with literals, meaning we type in the value of our array. We're not going to use that as much in this class, but it is possible. So how do we index an array? Well, we just use our array name and then brace whatever index we want to access. So we want to access the first index, we would put a 0 right here. If we want to access the last one, we would put in array name.length minus 1. And we can use those index variables as regular variables, right? Once we index the array, that value we can use whatever we want. So if we have an array called numbers and we set numbers at index 5 equal to 10, then we create a new integer called new number. We set that equal to 15 plus numbers at index 5. New number would equal 25, which is 15 plus 10. Right? We're using this array index or index variable as a normal variable. Its value is used as any other variable. Right? I just want to show you an example of indexing into an array. So again, we have int numbers equals new int, size 10. Let's set number 0 equal to 14. So it's going to do as you expect. Numbers at index 0 is going to equal 14. Let's set numbers 5 equal to 78. Again, that's going to do as you expect. Numbers at index 5 will equal 78. Numbers 9 equals 3,829, and it's going to do as you expect, 3,829. So that's how you index into an array. That's how you access those different indices. You just use the index number. So 0, 5, 9 is what we used here, and those are the indices that were changed. All right, looping through array. And actually, before we get to looping, I'm going to show you that in code. So if we have this right here, int points equals new int 82. All right. Let's randomly generate some points. All right. I don't know what this player is scoring. Let's use a random number generator. Rand equals new random. And remember, just like the scanner, we can import random using the light bulb over here or Control-Shift-I. All right, from there, I don't know what's going on here, so let me do this source format. There we go. All right, from there, let's set this player's first game. So points at index 0 equals random dot next int. Let's say a random number between 0 and 30 for point 0. That's the first game. The second game, points at index I and 1 equals rand.nextInt. Let's say they scored a random number between 0 and 60. And actually, to make this easier, let's just say their points. They scored 25 points the first game, and they scored 15 the second game. Right? And then points at index 2 equals, they went for 64 points. Okay. So now each one of these points at index 0 will equal 25, points at index 1 will equal 15, and points at index 2 will equal 64. So if I print these out, system.out.println, game 1, they scored points at index 0. That's how many points they scored. Let's do game 2, system.out.println, game 2, plus points at index 1. That's the next index. And then system.out.println, game 3, plus points at index 2. Bam. So if I print these out, I should expect this to be 25, 15, and 64. And that's what you get here. So that's how you index into an array. You just name of the array, brace, and then whatever index, set that equal to whatever value. And then you can get the value by just doing the name of the array and the index. Okay. All right. So looping through arrays, just like we index the arrays, we can loop through arrays just as easily. Okay. And when looping through arrays, we know that there's a beginning and an end. The beginning of the loop will be 0. That's the first index. The end of the loop will be array name dot length. Because we're using, if you look down here at the code, for int I equals 0, which is the first index, I is less than array name dot length I plus plus. You may be wondering why we didn't do array name dot length minus 1. It's because we're doing I less than. If we did I less than or equal to, then we would need to do minus 1. But since we're doing I is less than, once it equals the length, which would be beyond our array, it'll break the for loop and we will never index into the array. We won't even hit that line. It will always be less than the size, right? All the way up to length minus 1. So this is how you loop through an array. So let's say we have our int numbers equals new int of size 10. We loop through this numbers array for int I equals 0. I is less than numbers dot length I plus plus. All right, we create our variable I. We're saying while I is less than numbers dot length, continue this loop, incrementing I each time by 1. And inside this loop, I'm setting numbers at index I equal to I times I, which we go to our first iteration. I currently equals 0. Therefore, numbers at I, or numbers at 0, will equal 0 times 0. Or if we do that equation, it equals 0. Bam. Our second iteration. Again, I equals 1 now. Therefore, numbers at 1, at index 1, will equal 1 times 1, or 1. Our third iteration, I now equals 2. Therefore, numbers at I, or 2, will equal 2 times 2, or 4. And there you go. This process would keep going. So our fourth iteration, now I equals 3. Therefore, numbers at index 3 will equal 9. We continue, iteration 5, I now equals 4. Numbers at 4 equals 4 times 4, which is 16. Sixth iteration, I now equals 5. Numbers at index 5 will equal 25, or 5 times 5. Seventh iteration, now I equals 6. Therefore, numbers at index 6 will equal 36. This process would keep going for each iteration. We're just multiplying I times I. We're setting numbers at index whatever equal to I times I. So whatever I equals will be our index, and then our value is I times I, which is pretty much I squared. This process would keep going. And that's how you would loop through an array and index the array. Right? Yeah. So let's do a couple of these examples right here. Initializing arrays with input values. So essentially creating an array based on user input, right? So how do we do that? So let's just put this down. Let's move this down a little bit. And let's create an array based on user input. So, of course, if we have user input, we need a scanner object, right? To create our scanner, we do scanner input equals new scanner system.in. That's our scanner. Remember, to import a scanner object, you can either click over here, import, or you can do Control-Shift-I. Okay. All right, so now that we have our scanner object, let's prompt the user to enter something. System.out.print, enter the size of array. All right, and we're telling the user to enter the size of an array. Then we want to read in whatever the user enters. Int size equals input.nextInt. Now we're reading in that size, that whatever the user types into the console, we're going to read that in. As a result of that, let's create an array of that size. Let's say a double array. Double, let's go with prices again, equals new double size. So if you notice here in my code, which is what we like to have, is no literal values. There's nothing in here that was literally typed except for this prompt right here, which is okay. Other than that, the values that we use in this code are completely dynamic and based upon whatever the user types in at runtime, which is good. Then so I can show you this, int I equals 0. I is less than prices dot length I plus plus. Now we're looping through our array, and I'm going to print out system.out.println. I'm going to print this out, prices at index I. I'm printing out whatever that price is. I hit run, it should be a bunch of zeros. Size of the array, I'm going to say 15, and it should be 15 zeros down here. All right. And that's how you print out an array. That's how you loop through the array and print it out. Okay. The next thing on this list is initializing arrays with random values. So instead of reading in that from the console, let's use a random value. So again, we need our random object down here, up here. We can do away with our scanner. We don't need that anymore. And the only difference, we don't need a prompt. The only difference now is to change input to rand. And the max number I'm going to say is 100. Now it's going to randomly create an array of size whatever. So this one has a fairly large size. I don't know what it is. Let's print that out. System.out.println size. I print this out. It should tell me the size of our array, 36. We're printing it out again, 15. Do this again, 19, so on and so forth. It's going to be a random number. And we're initializing an array based on this size over here. So that array has a dynamic size each time we run the program. It's not set in stone. All right. So back down, let's go down to our points example again. Any questions about initializing it based on input or random variables? Any questions? That's what your lab and homework will be based on. So ask your questions now or ask them on Friday. Remember, I will not be on campus. All in-person classes have been moved online for this week. So it will be virtual Zoom again. Any questions about initializing the arrays, about arrays? I don't mind stopping and going back. If you want to put it in the private chat, if you have questions, please let me know.
You are posting this on Moodle after this, right?
I will post it, yep, on the class website, not Moodle.
Well, yeah, that's what I meant. Sorry.
You're good. All right, well, I'm going to keep going. All right, so let's get back to our points example. I'm just creating a random object again. Instead of explicitly saying what the points are, for each game, let's just do a random number. Let's create a random number for those. So the first thing we need to do is loop through our array. And then for each index in our array, let's give this player a random point total, right? I don't really know what their point totals are, but let's randomly generate it. So points at index I equals rand, and let's say this is James Harden, for example. He scores a lot of points. So let's do random numbers between 0 and 60 for each game, because you never know how many points he'll score in a given game, okay? All right, so if we print this out actually we can print it out in the same for loop that we created. So system.out.println points I. So we can see what his point totals are. Let's see down here. Basically what I'm doing is looping through my array. For each index in our array, we're creating a random integer between 0 and 60. And then I'm printing out that index. So we'll see what it is. All right, let's go to the top. We see game 1, he only scored 7 points. But then he scored 21, 34, 6. This guy, James Harden, is not very consistent apparently. 21, 7 again, but then he went off for 41, 16, 14, went off for 54, 45, 27, so on and so forth, right? For 82 games, he played the whole season, which is unlikely in today's NBA. All right. So if we want to get his average points per game, obviously what we need to do is sum up all the numbers, right? So we got to sum all these up. We need an integer sum equals 0. And then let's not print this out. Let's just calculate our sum. Sum plus equal points I. We don't want to do sum plus equal ran.next int 60 because that will get a random number again. We want to actually sum up this index, right? Whatever was stored into that array. And then the average, double average equals, or actually points per game equals sum divided by points.length, right? The full length of our array will give us our points per game. And then let's make sum a double, just so that our conversions work properly. And then system.out.println average or points per game. And then we concatenate his points per game. If I run this, it should add up all these, add a random number to our array, then sum up all those numbers. And once we have our sum, we calculate our points per game down here, and then we print it out. So he's averaging 28, that's actually fairly accurate, 28.28 points per game. So you think about this, any sports leagues you watch, anything like that, apps that you use, a lot of those apps are using arrays in the background, right? To store all the player stats, player information. They're just holding those in arrays. And with an array, there's many different things you can do, right? We can find the highest scoring game. We can find the lowest scoring game, right? And those are fairly simple to find. So we found our points per game here. Let's find his highest scoring game of the season. Double highest equals, again, anytime we want to find the max of something, we must set it equal to the min. I know that's counterintuitive, but initially we want the minimum possible value. That way, when we go through here, we can find anything greater than it will replace our highest. And I'll show you what I mean by that. So to find the highest, we must loop through our array again, int I equals 0. I is less than points.length, I plus plus. And then we want to check to see if whatever number is at the current index is higher than our current highest, or current max, let's say max. If it is higher or greater than, we want to set our current max equal to that number, right? Because it's greater. So if points at index I is greater than max, we set max equal to points at index I. And once this for loop finishes, we should have our max number. So now system.out.println highest scoring game was plus max. That should give us our highest. If we want to find the minimum, again, we could do the same thing. Int min equals integer. Instead of min value, let's do max value because we want everything less than this. If points I is less than min, meaning it's lower than, min equals points at index I. All right? And each time it's going to go through this for loop and check to see if points is greater than our current max. If that's true, set our current max equal to points, because that's a bigger number. If points I is less than our current min, set min equal to that points I. That means it's a lower number, and we're trying to find the minimum possible number. So we can kind of copy and paste the same line. Instead of max, we're looking for the lowest possible number. We found it already. Lowest scoring game was plus min. Now when I run this, we've got our average, our points per game, plus our max and our min. Oh, wow. All right, so we're still back at 28.73 points per game. His highest scoring game was 59 points, and his lowest scoring game was 0. So again, they're not very consistent, but their average is pretty good. That's when, in a lot of statistics, average can be misleading. Usually you want the median. All right. So there we go. That's our points per game. Highest scoring, our lowest scoring, I basically found the max and the min. And so the last thing I want to cover for arrays, well, one of the last things I want to cover is how to sort an array. For this example, you may not want to sort this because order matters, right? 0 to whatever matters. But in another example, maybe order doesn't matter and you want to sort it. I'm just going to sort this right now, just for this, so you can see how it works. And it's very straightforward. All you do is type arrays, or array, I'm sorry, dot sort. Now, actually, I think it is arrays dot sort. And then you pass in your array. That sorts your array from smallest to biggest. So all this code we had up here now is irrelevant, right? We don't need all of this. I could have did this right here. I could have sorted my array, delete this for loop, because we know once an array is sorted, the last index will be the biggest number, the first index will be the smallest. So how do we get the last index? We do points at index points dot length minus 1. That would give us our last index. Our minimum value would be points at index 0 because we sorted the array. I run this, and now his lowest scoring game was 1, right? But his highest scoring game was 59. All right. So there you go. I found the max, the min, all that good stuff. If order matters, you may not want to sort your array. But if order doesn't matter, you can sort it. Any questions? All right. Well, I want to get to the next chapter, next slide, so whatever was left in this one is okay. The enhanced for loop, it just means that you can loop through the array. And each time you loop through the array, whatever this variable is will equal your array index. And I'll show you that in the code. So if I have this, if I still have the same points array, I can do for game, or I'm sorry, int game in points. So now each time I loop through this points array, game will equal whatever those points are. So I could have did this up here. Hold on, let's delete all this sorting stuff. I could have did this up here. Instead of this long for loop, I could have did int game in points. And then I could have just did if game is greater than max, max equals game. If game is less than min, min equals game. Right? Each time it loops through, game is going to equal the next index in points. However, the issue is we can't set anything inside points equal to anything, right? We can't do points at index game equals 342. I'm sorry, 34. We can't do that because game is not an index. It's actually the value. And in this for loop, we don't have the index, so we can't do that. We can only do this right here. We can only access the value, not change it. Enhanced for loops, we probably won't use a whole lot in this class, so I just wanted to go over it so you see what it is. All right, that's it for arrays. So if you have any questions, ask now. We're about to move on to a different topic, somewhat related. All right.